Okay, so let's talk about rate limiting. And I don't mean the boring textbook definition. I mean the kind of thing that wakes you up at 2 a.m. when the API is completely on fire. You've seen it, you've probably caused it, the 429 error, that is too many requests error. Sounds like a trivial thing until your entire service is throttled and you don't know what's the reason for that. Today we're going three algorithms deep. One is token bucket, second one is leaky bucket, and third is sliding window. And by the end of this, you'll actually know which one to reach for and why. So why does rate limiting exist at all? Think about it this way. Your server is basically a bucket. It can hold a finite amount of work at any time. When traffic comes in normally, one tap, steady stream, everything is fine. But the internet is not that polite, right? You get a traffic spike, maybe someone's script goes haywire, maybe you got posted on Reddit, maybe it's an actual DDoS, suddenly you've got 50 tabs open at once, and the bucket just overflows. Rate limiting is the valve that controls the tap. It's not just about keeping bad actors out, it's about keeping your own legitimate users from accidentally torching your infrastructure. Alright, here's a plan. We are covering three algorithms today: token bucket, leaky bucket, and sliding window. They all solve the same fundamental problem, that is controlling request flow, but they approach it completely differently. They have different trade offs and they are suited for different use cases. Let's go through each one. Token bucket. This one's my favorite to explain because the mental model just clicks immediately. Imagine a literal bucket, but instead of water, it's filled with tokens. Every second, some number of tokens are dropped into the bucket, and every request that comes in takes one token out. Here's the key thing: the bucket has a maximum capacity. If tokens fill up and nobody's making requests, they just accumulate up to that limit. Which means if you've been quiet for a while, you can actually burst. That is, you can send a bunch of requests all at once because you've got tokens saved up. But the moment you run out of tokens, your request gets dropped until the bucket refills. That's it. That's the whole thing. The bucket size controls your burst tolerance. The fill rate controls your sustained throughput. So you have two knobs and it is a very intuitive design. Under the hood, the implementation is pretty elegant. You store two things, that is the current token count and the timestamp of the last refill. When a request comes in, you first calculate how many tokens should have been added since the last timestamp, add them, which is capped at capacity, then check if you have at least one token. If yes, subtract one and allow the request. If no, reject it. The brilliant part is that there's no background thread running the refill. You calculate it lazily on each request, which means it's very cheap to implement. Where is bucket token used in the real world? Stripe uses it for their API rate limits. AWS uses variations of it for service quotas. It's everywhere in API gateways. Next is Leaky Bucket. It's a different name, different behavior, same core concept, but inversion is actually what makes it interesting. With Token Bucket, the output can burst. That is, you stored up tokens, you can spend them fast. Leaky Bucket flips this. The bucket accepts the request at whatever rate they come in, but it processes them at a fixed constant rate, like a small hole at the bottom of a bucket that can only drip so fast. If requests pile up faster than they drain, the bucket overflows and those requests get dropped. You never get a burst on the output side. It's always smooth, always the same rate. This is super useful when the downstream system can't handle bursty traffic. Imagine a payment processor or a database that needs predictable even load. Token bucket is flexible and leaky bucket is disciplined. Keep that in your mind. Now the next one is the sliding window. This one solves a specific flaw that fixed window counting has, and once you see that flaw, you can't unsee it. Fixed window is simple. You allow 100 requests per minute, you count them, minute resets, counter resets. But here's the problem. What if someone sends 100 requests at 11:59:59 seconds and another 100 at 12 o'clock 1 second? Technically, both are within their respective windows, but you just got 200 requests in 2 seconds. That's a boundary exploit. Sliding window fixes this by making the window roll continuously. Instead of how many requests in this clock minute, it's basically how many requests in the last 60 seconds from now. The window slides with time. This is more precise, more fair, and much harder to game. The trade off is that it's more expensive to compute and store. That is, you need to track the timestamp of every request, not just a single counter. Redis sorted sets are common implementation for this. Let's put them side by side because at this point, if you are a bit overwhelmed, that's okay. They really do look similar, and the difference is in the details. Token bucket allows bursting, memory efficient, great for APIs where you want to be flexible with clients. Leaky bucket has no bursting, constant output rate, perfect when downstream system needs smooth and predictable load. And think of queues and payment systems. Sliding window is most precise. There are no boundary exploits, but it costs more memory since you track individual request timestamps. Great for user facing rate limits where fairness really matters. So none of this is universally better. You pick based on your constraints. Now let's talk about where you actually see these in wild because it makes them stick. Stripe uses Token Bucket for their API. It's documented in their API reference. They give you burst allowance. GitHub's API does the same thing. The reason is that developers make requests in batches. You're not steadily querying every second. You hit GitHub when you open your terminal and run a command. Leaky Bucket pops up in a message queue systems. Anywhere you have a producer consumer pattern where the consumer needs predictable throughput. Sliding window is what Redis backed rate limiters almost always implement. So Cloudflare uses variations of it. Nginx has rate limiting modules built on similar principles. So the reality is that most production systems are hybrids. You might use sliding window for per user limits and token bucket for global API limits. Okay, now let's go a bit deeper because knowing the theory is one thing, and here's where people actually mess up. Number one, distributed systems. If you have 5 servers and each one tracks its own counter independently, your effective rate limit is 5 times what you think it is. You need a centralized store, and Redis is the classical answer for that. Number two, we have clock skew. That is, sliding window cares about timestamps. If your servers don't have synchronized clocks, and they often don't perfectly, you get subtle bugs that are very hard to diagnose. Number three, be kind to the clients. If you rate limit a request, send back a retry after header, tell them when they can try again. Otherwise, they just hammer you, which makes everything worse for everyone. And number four, don't over limit. Rate limiting is a protection mechanism, not a punishment. If your limits are so aggressive that normal users keeps hitting them, you've got a configuration problem and not a traffic problem. So how do you actually choose? Here's the mental shortcut I use. Ask yourself, does the downstream system care about bursts? If the answer is yes, it can't handle bursts, use leaky bucket. If no, move on. Do you need clients to be able to accumulate capacity over quiet periods? Classic token bucket. Do you need most precise gaming resistant limits on per user basis? Sliding window and budget for Redis infrastructure. If you're building an API from scratch, I would honestly default to token bucket. It's the most intuitive to reason about, well understood, and easy to explain to clients when they ask why their requests are being throttled. Alright, that's a wrap on rate limiting algorithms. Quick recap. Token bucket for burst tolerant APIs, leaky bucket for smooth constant output, sliding window for precision. If there's one thing to take away, rate limiting isn't just about blocking bad actors, it's about building systems that stay predictable under load. And choosing the right algorithms means your system degrades gracefully instead of catastrophically. Drop a comment if you have hit a rate limiting bug in production. I would love to do a follow up video on real incident stories. Subscribe the channel for more such content. Thank you.